Zeal Education Society, redefining excellence.
Hello everyone, I am Dnyanganga, first year diploma student of Civil Department from Zeal Polytechnic, NARHE, Pune. My topic is prepare charts displaying volume of irregular shapes using concepts of integration, and I was very much guided by Professor Padwal sir. So my first point is volume by integration. If a region in the plane is revolved about a given line, the resulting solid is a solid of revolution and the line is called the axis of revolution. When calculating the volume of a solid generated by revolving a region bounded by a given function about an axis, follow the steps given below. First, sketch the area and determine the axis of revolution. This determines the variable of integration. Second, sketch the cross section, disc, shell, washer and determine the appropriate formula. Third, determine the boundaries of the solid. Fourth, set up the definite integral and integrate. Then next, how can we measure volume of irregular shapes? You can measure the volume of any irregular shape solid with a cross section that is a function of x. In some cases, these solids are harder to describe than they are to measure. For example, have a look at this figure. A solid based on two exponential curves in space. The solid in the figure consists of two exponential curves. One described by the equation y is equal to e raised to x and the other described by placing the same curve directly in front of x-axis joined by straight line. The other sides of solid are bonded planes slicing perpendicular in a variety of directions. Notice that when you slice this solid perpendicular with the x-axis, its cross section is always an isosceles right angle triangle. This is an easy shape to measure, so the slicing method works nicely to measure the volume of solid. Then the first step is find an expression that represents in the area of random cross section of the solid. The triangle on the y-axis has a height and base of 1, that is e raised to 0, and the triangle on the line x is equal to 1 has a height and base of e raised to 1, that is e. In general, the height and base of any cross-section triangle is e raised to x. So here is how we use the formula of the area of a triangle to find the area of a cross-section in terms of x. A is equal to half b into h equal to half e raised to x into e raised to x is equal to half e raised to 2x. Second, use this expression to build a definite integral that represents the volume of the solid. Now that you know how to measure the area of a cross section, integrate to add all the cross sections from x is equal to 0 to x is equal to 1.
Zeal Education Society, redefining excellence.